I am Naveen Kumar, Professor of Mechatronics Engineering, Hindustan College of Engineering and Technology, Coimbatore. So here we are going to discuss about the water jet machining process. So what is the principle of water jet machining? What is the working of water jet machining? So here the key element of water jet machining is water. In general, water jet travels at a velocity as high as which is equal to Mach 3, which is about 3740 meter per second. It is more than a speed of a bullet when it's triggered from a gun. So when the water strikes a workpiece surface, therefore the erosion force of water removes the material rapidly. So therefore it acts like a sharp, which acts in a narrow groove in the workpiece material. So it is also known as hydrodynamic machining. It uses a fine, high pressure and high velocity of water which force direct at the workpiece surface cause cutting of the work. So main principle, the kinetic energy of the water jet strikes the workpiece is reduced to zero. Therefore, the bulk of kinetic energy of jet is converted into pressure energy. If the local pressure caused by the water jet exceeds the strength of the surface which is being machined, so therefore the material from the surface gets eroded and a cavity is formed. So water is the most common fluid used. So it is readily available compared to other material. It is very cheap. But additives such as alcohols, oil products, and glycerol are added when they can be dissolved in water to improve the processing. So equipment such as we needed the basic components. In this diagram we can see that hydraulic pump, intensifier, accumulator, high pressure tubing, jet cutting nozzle and a crusher. So typically some of the work material which added soft metals, paper, cloth, wood, leather. Sometimes you can use a rubber. So if the work material is brittle, it will be fractured. It is ductile. It will cut well in this process. So hydraulic pump, so powered 30 kilowatt electric motor. So here the hydraulic pump is used to convert the electric energy into a fluid pressure by means of electric motor to drive the pump. The fluid pressure is then delivered by the hydraulic fluid to the actuators at the required pressure level and the volume of water. The hydraulic pump offers complex flexibility for cutting and cleaning applications. It supports a single or multiple cutting stations. So intensifier. The intensifier is mainly used to convert the energy from the low pressure fluid to a high pressure fluid. It provides a fluid power to the reciprocating piston in the intensifier. The intensifier assembly having a plunger on each side of the piston it generates pressure in both directions. So during the plunger, the inlet stroke filter water enters the high pressure cylinder through the check valve assembly. So and same, the accumulator it maintains the continuous flow of the high pressure water and eliminates the fluctuations in the water pressure. The high pressure tubing it transport the pressurized water to the cutting head. So typically the diameter of the tubes varies from 6 to 14 mm diameters. The equipment allows for flexible movement of the cutting head. The cutting actions is controlled either manually or through a remote control valve specialized designed for this purpose. Then about the cutting nozzle. Here, the nozzle provides a various stream for optimum cutting. At low density, soft materials can be considerably machined. So nozzles which normally made up of synthetic sapphire, that's called as tungsten filaments. About 200 hours of operations can be expected through this type of material. A longer nozzle life can be obtained through multi-stage filtration. The compact design of water design, the cutting promotes integration with the motion control system ranging from two-axis tables. So then the catcher. So catcher is mostly it is acts like a reservoir for collecting debris which contains in the water jet.